We are nearly there, exoplanet detectives.
In our solar system, planets are usually divided into two categories, rocky like Earth and gaseous like Jupiter. However, exoplanets can be very different from the neighbouring planets we are used to.
I think we need the help of one of our exoplanet experts again. Let's send a quick email. Hi Davide. Ali and I have been investigating exoplanets with our team of space detectives. We would like to understand how we can determine an exoplanet's composition. Are you available for a quick video chat? Send. Oh. Hi Davide, thanks for calling us.
My pleasure. I have been working on the composition of exoplanet for many years, and trust me, it's not a trivial matter. With the data you have, you can estimate the exoplanet mean density. This will give you an idea on the internal structure of the exoplanet. To work out the density, you need to know the exoplanet mass and its volume. I give you some examples. Our planet, the Earth, is a rocky planet and it has a mean density of 5.5 grams per cubic centimeter. Europa, one of Jupiter's icy moons, has a mean density of 3 grams per cubic centimeter. This moon is believed to have a 15-25 kilometer thick surface made of ice floating on an ocean that could be as deep as 100 kilometers. Jupiter is the largest planet in our solar system and is a gas giant planet. It has a mean density of 1.3 grams per cubic centimeter and is composed of hydrogen and helium.
Very interesting. I wonder what the composition of Cal-3b is. Let us estimate the mean density of Cal-3b. Pause now and we will present our results straight after.
Let's now analyse Cal-3b data as an example. In the first exercise, we already determined the radius of Cal-3b. The radius of the planet is equal to 17.5 times the radius of the Earth, around 111,600 kilometres. By knowing the radius, we can calculate the volume of the planet, assuming they are a perfect sphere. The volume of the planet is proportional to the planet's radius cubed. Cal-3b's mass is 617 times the mass of the Earth, about 3.685 times 10 to 27 kilograms. The exoplanet's mass is not possible to determine from CHEOPS data using transit photometry. It was determined from previous observations using a different technique called radial velocity and is part of your case file. The mean density of the planet equals the ratio of the mass and volume of the planet. In this case, we determined it to be 6.3 times 10 to 11 kilograms per cubic kilometre, which equals 0.63 grams per cubic centimetre.
From this low density, we can deduce that Cal-3b is a gas planet, but this density value is much smaller than Jupiter's mean density. How different from our solar system, so interesting!
To learn more about the composition of exoplanet, astronomers use a different technique, which is called spectroscopy. With this technique, the light we receive from the star or from the exoplanet is split in different wavelengths, which are basically colors. And we can determine what is the composition of the atmosphere of an exoplanet or even learn about the cloud coverage. But I think this is a little bit more advanced and you would have to take a few extra exoplanet detective lessons. I think you're finished with your investigation, right?
We have concluded our investigation.
We have discovered that Cal-3b is an exoplanet orbiting a star bigger than our Sun at 690 light years away. This exoplanet orbits very close to its host star, more than 10 times closer than Earth to the Sun. That is why it's very hot and puffy, and we call this type of exoplanets hot Jupiters. Unfortunately, they are very unlikely to host life.
Congratulations, detectives.
You have successfully characterized Cal-3b, but your work is not finished. There is one more case file to complete, TOI 560C.
Are you ready to start investigating TOI 560C?
Use your new detective skills, complete your TOI 560C investigation and submit your report for a chance to win the best project prize.
The deadline for submission is 14th June 2023. The winning teams will have the opportunity to participate in a webinar with Physics Nobel laureate Didier Queloz on 17th July 2023, as well as receive ESA goodies.
Go to hackanexoplanet.esa.int for more information.
Good luck, detectives!